Part two of this week's topic is on direct regulation, on how government can impose these standards and regulations to meet different energy policy needs. First of all, what is direct regulation? So it's also known as command and control. These are prescriptive directions or regulations that government can enforce on different parts of the energy system or different parts of production processes. They can impact on inputs to a system. For example, they can direct the minimum share of biofuel. I'll give this as a more detailed example later. They can directly ban inputs. They can say 0% share of lead in petrol, for example, banning lead. They can also impact on the process or the technology, and an important class of this is emissions performance standards or energy performance standards. So that's directly regulating what performance in terms of energy intensity or energy efficiency cars or buildings or devices have to reach. And the government can put that on the industry manufacturing the device. Often it's easier to target industries and manufacturers rather than end users. You can also sort of impose design standards. For example, here every car has to have a catalytic converter to reduce the pollutions. So yeah, can prescribe these aspects of the production process. It can also regulate outputs. So, for example, we'd have EU directives limiting the sulfur pollution from a single coal-fired power plant to prevent acid rain and air pollution from sulfur. Can ban the output of CFCs. CFCs were the cause of the hole in the ozone layer, so ban any emissions of CFCs. These regulations can impact can be location specific. For example, in Ireland, certain urban areas, it's banned to burn smoky coal. Only smokeless coal can be burned because the air pollution kind of gathers in a certain location. It can then do outright bans on different things. For example, if you look at the health sector, then the parallel here is the ban is on, say, smoking indoors in pubs and restaurants. For example, as well, oil boilers will be banned from new built homes by 2022, and gas will be banned by 2025. Existing houses will be allowed to keep these, but people who build houses won't be able to put these in. So this is a very common form of environmental regulation, and it would go back to, say, the 70s when these forms of regulations were highly successful in reducing very toxic things. For example, the lead in petrol was one thing. Very successful in cleaning up very dirty industries. Something is so bad it has to be forbidden. On the other hand, it has disadvantages when coming to energy policy, and I'll go through some examples in a while. But first example I want to give you from Ireland and in many countries is obligation on fuel suppliers. So the EU Renewable Energy Directive sets out a national mandate for renewable energy. Ireland's overall renewable energy target for 2020 for this year is 16%, and we're allowed to, through heat and electricity transport, meet that how we want to, but there's also a separate target for renewable energy from transport. So member states set individual targets for heat and electricity. Every member state has to achieve a 10% share of energy in transport coming from renewable energy. So in 2010, that led to the development of this biofuel obligation scheme in Ireland, and the same is the case in many different countries. So this is a certificate-based scheme, and it sets out an obligation on all oil fuel suppliers on road transport fuels that they must contain a certain percentage of environmentally friendly, biofuels across the general mix. Now, some biofuels might have a high life cycle emissions profile, so basically all the emissions from transporting and growing them and so on might be high. But the EU Renewable Energy Directive stipulates that only biofuels which meet certain sustainability requirements can be used to count towards this. Also, biofuels which don't negatively impact land use, so they're not basically chopping down rainforests to create these biofuels. The current target, or the current, it's not a target, it's a standard, it's a directive. It sets out that 12.3% by volume of motor fuel has to be bioethanol blended in petrol, or biodiesel blended in diesel. The purpose of this is twofold. It first of all obviously helps Ireland meet that EU directive, but it also helps reduce emissions by displacing fossil fuels. As I said, it's certificate based, so basically the supplier has to get certificates when it puts biofuels into the mix, and then it has to show these certificates to prove that when it reports to the national agencies that it complied. And there are also double credits for so-called second generation and third generation biofuels. These are biofuels which come from basically they're not competitive with fuel sources. And those come from waste, or from algae, or from these sources that aren't directly, as I said, competing with food. Virtually all biodiesel used in Ireland has qualified for these double certificates since 2012. All have qualified since 2016 and 2017, but no biogasoline qualifies for double certificates. So that means that basically, if we used all second generation biofuels, then we'd only have to blend 5% by volume in order to meet the 10% target overall, because we'd get double credit for these sort of more environmentally friendly fuels. Here is a chart from the Sustainable Energy Authority of Ireland, from the Renewable Energy in Ireland report, which shows the biofuel production, imports and usage to 2017 in Ireland. You can see that basically the biofuel usage has been increasing very strongly. Some years basically it's been driven by this target, by this biofuel blending obligation. You can see here that the indigenous production of biofuels, which is mainly biodiesel, it has been flat, so we're not increasing our capacity, and we're meeting all of that additional increase with imports of biofuels. So 84% of our biofuels were imported in 2017. Another form of sort of blending obligation, which is commonly used globally, are called renewable portfolio standards, and they're commonly used in the US. So they're a regulation on electricity suppliers that they have to blend a certain amount of renewable electricity. Blending is probably the wrong word here when you're talking about electrons, but it means that it's an obligation on electricity suppliers that a certain amount of electricity has to be renewable. But we'll see later, for Ireland, we use more physical approaches to reach our renewable electricity targets. The second example I'm going to show you here is building regulations, which regulate, which one of the functions of building regulations is to impose energy performance standards. And I suppose the aim of building regulations overall is to provide for safety and the welfare of people in and around the buildings. And the first thermal insulation requirements for residential buildings in Ireland formally came into effect in 1979. So the first time that there was some sort of standard for energy performance came in 1979. And those regulations have been kind of strengthened, improved, and the regulations around those have been improved many times since. So they're set forth in Part L of the building requirements, which govern the conservation of fuel and energy. And in particular, since 2008, there's been a big sort of drive in improving these standards, and also in the sort of the, I suppose, assessment of their effectiveness, because that's as important. So in 2008, the regulations introduced the concept of the emissions performance coefficient, the EPC. That's the ratio between the actual energy performance of a building, calculated through this software called DEEP, and that of this reference building complying with 2005 regulations. So basically it takes a kind of a model 2005 house, and it stipulates how much energy saving per meter squared has to be achieved kind of in relation to that. So in 2008, that was set at 0.6. That means that basically 40% energy savings were required to this reference dwelling. And this is basically theoretical energy savings. It also introduced this concept of a building energy rating, a BER, and you probably are all familiar with that. If you're renting or buying a house or selling a house, you have to get this building energy rating certificate, which goes from sort of A1, which is the most energy efficient, to G. And so that measures the sort of kilowatt hours per meter squared, based on the thermal characteristics of the house, the windows, the walls, the roof, the insulation. Something that the energy standards also do is include mandatory contribution from renewable energy to thermal energy. Again, this is a regulation. So the government says new houses have to meet the A2 BER standard. So, you're breaking the law if you build a house that is less energy efficient than this. And these, so the 2019 regulations, these houses are 70% more energy efficient than those built under 2005 building regs. So there's a very, very strong sort of improvement in energy, theoretical energy efficiency at least. And also a lot of the heat is met by renewable energy. The heat there can be from biomass boilers. So you might see pellet boilers, for example. It can also be with solar thermal panels. If you put these solar thermal panels on your roof, can create a lot of hot water even in the winter if there's any kind of light, and offset the cost of heating up your water. A third type is a heat pump, which would be air or ground source heat pump, which kind of takes this ambient heat from the environment even when it's freezing outside and actually can produce heat in your house. So those are, you have to have one of these things in a new built house. These new dwellings, there's basically these energy performance, they're getting tighter and tighter all the time, and now new dwellings are called basically near zero energy buildings, or NZEB. These are from the 2019 building regulations. These have really improved the kind of quality of Irish houses and have reduced the energy intensity and emissions from Irish houses. But there's also something called the rebound effect, whereas if you're at all familiar with an kind of older house, which is not very well insulated, people wear jumpers and scarves inside, you take a hot water bottle to bed, you light a single room with a fire, and you don't heat the house to the house uniformly to a certain standard. But modern houses are actually, there's a thermostat, and so you set it at 21 degrees, and the whole house is that for the whole year. So there's this big rebound in terms of behavior. So the theoretical energy savings are certainly not matched with actual energy savings, which is quite interesting. But there's the rebound effect, but there's also many co-benefits of energy efficiency, and basically high fuel poverty, high bill prices, air pollution are all caused by poor building standards, and so building standards have been very kind of good at reducing emissions, as well as a host of other co-benefits. On the other hand, Ireland still has a very, very high amount of carbon emissions per dwelling, and emissions. This is basically megawatt hours per dwelling per annum. This is basically shows how Ireland here is basically Europe's top emitter in terms of emissions per dwelling. That's because we have the highest share of fossil fuels in our home heating in all of the IEA member countries. We've basically almost all of our homes are fueled by gas, oil, and peat and coal, or open fires like that. We've very low electricity, very low biomass, or heat pump usage. So we still have a very long way to go to sort of meet even EU standards, and that's why the building regulations have been very helpful in this. You can see our energy requirement come down a lot, but it's still not sufficient to meet our emissions reduction targets. Last slide on this section is to just discuss some benefits and drawbacks of the regulation. If you're reading out like a classical economist book, economists don't like regulation. They say it kind of impedes the operation of the market. Especially it can reduce the flexibility and innovation that manufacturers can use to reduce emissions if they're over prescriptive. For example, is the biofuel blending obligation the best way, the most cost effective way of reducing emissions, especially if we're importing biofuels? If we just put a carbon price, wouldn't that just create a market signal and which reduce with more certainty? But there are benefits. So, as I said, in the case where pollution is very highly toxic and it just needs to be banned, that kind of regulation is very useful. It's preferred when the costs to different forms are uniform and the pollution is uniform. So basically, the different parts of the market are not distorted too much. This is, for example, in the case of biofuels. So the market, they're selling a uniform product. Every car kind of takes the same kind of petrol, so it's not onerous and so on. And also, I think these sort of regulations have big benefits when market solutions won't deliver the required result. So the EU imposes a target on Ireland. We'll be fined if we don't meet the 10% renewable energy and transport target. So we have to, it's just an obligation on fuel suppliers, for example. It's also, the market doesn't drive efficiency as much as it should because of various reasons, because people don't value those long-term emission savings, especially from a long-lived asset like a house. So, basically consumers don't drive the efficiency of houses. So it's very, or even cars, but the drawbacks include that it's really sort of a blunt instrument. It's a one-size-fits-all regulation. It requires the government to know a lot about the technology and know a lot about the production process. So it needs substantial knowledge on behalf of the regulator. So it's less effective when there's sort of heterogeneous, when there's lots of different types of actors and different types of emissions. And the cost of compliance and administration can be high. So if something is effective, there has to be a lot of paperwork, a lot of kind of checks and balances to make sure that these regulations are adhered to, or there has to be kind of a lot of administration and bureaucratic, and that can be another downside of regulation.